Welcome to yet another video segment of CSE 341 Microprocessors lecture. Today's video segment is going to be all about the hardware specifications of 8086 microprocessor. This lecture would entail looking at the IC in detail, the various pins it has, and their functions. There are many different types of ICs, as you can see in this diagram. They all look different, have different number of pins, their organizations are different. Now, 8086 is of this nature, which has been highlighted here. This kind of pins are known as DIP or dual inline package. As you can see in the diagram, the IC is of a rectangular nature and has a row of pins on either side of the package. 8086 has 40 pins, so it's known as a 40-pin DIP. DIPs have another characteristic, and that is having a notch, as can be seen in this diagram here. This notch helps in identifying the top of the IC. Using this diagram to explain further, we can see that the IC has a notch, and this notch would indicate the top of the IC. The notch also helps in identifying the pins of the IC. At the top left corner is always the first pin, that is pin number 1. And the pins are numbered in a counterclockwise nature, as shown in this diagram. So you can see that the pins move from 1 to 8 on one side, and then from the bottom top we move from pins 9 to 16. 8086 is numbered in a similar fashion. 8086 has 40 pins, and you can see that the pins are numbered in that nature. So on the left side, we have pins 1 to 20 from top to bottom. And then on the right side, we have pins 21 to 40 from the bottom to the top. Before we look at all the pins of 8086 and their functions, let us have a quick recap of all the things we have learned so far. We know that 8086 is a 16-bit microprocessor, meaning that it has a 16-bit data line. We also know that it has a 20-bit address line, which can access 2 to the power of 20 different memory locations. Each memory location holding only 1 byte. Since each memory location can hold only 1 byte and we have 2 to the power of 20 memory locations possible, then 8086 can access up to 1 megabyte of memory. All these points are very important for us to remember to understand today's lecture and for all other lectures. Let us now start with the pin descriptions. From this diagram, we can see that pins 1 to 40 have been annotated with some symbols. However, pins 24 to 31 have 2 columns of descriptions. This is because 8086 has 2 modes of operation, the min mode and the max mode. When 8086 is working in the min mode, then pins 24 to 31 have these functions. And when it's in the max mode, then the pins function as shown here. We are going to understand what min mode and max mode are a little later. And also the particular pin functions. Let's now start with VCC, which is pin 40. This is the power supply pin and it's an input pin. 8086 needs 5 volt of electrical supply to function. And interestingly, it has two ground pins, pins 1 and 20. AT86, like all other ICs, need a clock impulse. This input controls the operation of the microprocessor. It synchronizes the different parts of the microprocessor to function together or correctly. The frequency of the clock impulse can be of different values, that is 5, 8 or 10 megahertz depending on the version of 8086 you're using. The duty cycle of 8086 is 33%, meaning it is on for 33% of the time and off for approximately 67% of the time. The period of the cycle has been shown in this diagram. And to complete one bus cycle, we need 4 time periods, which are usually referred to as T1, T2, T3, and T4. This bus cycle we'll come to learn a bit later on in the lecture can be read cycles or write cycles. And we're going to look at this in detail. The next set of pins we'll look at are the AD0 to AD15 pins, which are pins 2 to 16 and pin 39, as shown in the diagram on the left. These pins are bidirectional, meaning they can be input pins or output pins. AD pins can be either used to carry address lines or address bits or data bits, depending on the time period. During the first time period, T1, these pins carry the address bits, and they carry 16 bits of the address. During the rest of the time cycles, they carry data bits. AD0 is the least significant bit and AD15 is the most significant bit in this 16-bit combination. AD0 to AD7 carry the low byte and AD8 to AD15 carry the high byte of the data. We know that an address is 20 bit long. We have seen that AD0 to AD15 pins carry 16 bits of the address. The remaining 4 bits, which are the highermost bits, are carried by the pins 35 to 38. Pins 35 to 38 are also multiplexed like the AD pins, meaning they can serve two functions depending on the time period. Pins 35 to 38 carry either address bits or status signals, depending on the time period. These pins carry the address bits during T1 and status signals during the rest of the periods. Status pins S3 and S4 are known as segment identifiers. They function as follows. For example, a combination of 00 will select the extra segment. A combination of 11 would select the data segment, and so forth. Pin 34 is known as the BHE or S7 pin. This is an output pin and is also active low, meaning it gets activated when the logic at this pin is 0. This pin is used to indicate that the high byte of a data is being transferred through AD8 to AD15 pins. This pin is related to memory bank to select the odd or high memory bank. We'll learn more about memory banks in the later chapters. Pin 32 is another active low pin that is used to indicate that the processor is currently carrying out a read operation from the memory or an input device. This is usually low during the T2, T3, and TW states of the read cycle. The TW state, which is also known as the wait state, is optional. It may or may not be present, and we'll learn more about these states at a later time. The test pin is related to the wait instruction. After the execution of a wait instruction, the microprocessor enters an idle state and continues to be in this state until the test pin is set to 0 or low. The ready pin is an acknowledgement from a slower input-output device or memory device to indicate that the device is ready for data transfer. If, however, the input-output or memory device is not ready, then it sends a low signal to the microprocessor and the microprocessor enters an idle or wait state. The wait state is an extra time period that the microprocessor adds between T3 and T4 to allow the input-output device or memory device to get ready for data transfer. The reset pin is used to reset the microprocessor, and in order to do so, it must be high for at least 4 clock cycles. 8086 has 2 pins reserved for interrupt requests. The first pin we'll discuss is the NMI pin. NMI stands for non-maskable interrupt, meaning these interrupts cannot be ignored by the system and must be serviced by the system at the end of the current instruction. The next pin is the INTR interrupt pin, which is used to request for a hardware interrupt. This interrupt can be masked, meaning it can be ignored by the microprocessor. This brings us to the end of the discussion of the pins that are common to both the minimum and maximum modes of the 8086 microprocessor. We will continue our next video segment with the pins that are particular to the maximum and minimum modes.